And all right, welcome everybody. I'm Marco, and today I will show you how we moved the tier application for a monolith to a multi-module application. And this will not be a one-on-one talk about modularization, but I will rather focus on the journey and what we needed to do in order to be able to modularize. So a little bit of context. The tier application let user rent different vehicles like a scooter, bike, and mopeds. And when it started back in 2018, it was like every little application with a single module, a few people working on it. Then things luckily changed, and more features came. The app became famous, and so we started integrating more feature, and everything grew. Also, the team grew. There were more people joining, and so we ended up with a big monolith with a lot of code in it, and people working in the same module. So there were conflicts. There were not clear ownership of code, and also build time decreased because, yeah, only a single module is not smart for Gradle. So we decided then to move to a more optimized way with multiple modules and a multi-module structure that gave us a lot of benefits. Because if you're going to have multiple modules, then you're going to simplify development. Because with multiple modules, you're going to have separation of concern. You're going to have clear interface for different teams to start using a specific feature. And with that, you're going to also have kind of for free more ownership, more cleaner responsibilities, because one or multiple teams can own can own multiple modules. And with that, we can achieve the most important thing on this thing, that is build time. Because sometimes Gradle is smart enough to parallelize work, and so with multiple modules, it can build multiple modules in parallel, so hopefully less build time. The downside of everything is that there is not a perfect recipe and a perfect way of doing things, because every project is different. So some stuff can apply to a specific project. Sometimes some things cannot apply to another. So you have to find your own way. But likely the general concepts are valid for every project. So in this talk, maybe every single detail will not gonna be okay maybe for your project, but the general concept will be. So the first step before actually moving into the writing code is some investigation or research, because you have to decide which modularized architecture you want. Again, the implementation is different, but the concepts are the same. And so usually the standard modularized architecture is something like that. So with different types of module that are in different layers. So usually there are modules that can be defined as a libraries. So external libraries are pieces of code that does something specific. So for example, like storage, networking, logging, and stuff like that. Then usually there are more modules that abstract a specific feature. So for example, the entire onboarding, the entire settings, the home screen, et cetera, et cetera. And then at the topmost, there is the Android application that usually is only one, but can, of course, there could be also multiple applications if you have a multi-flavored application. And this is the module that basically orchestrates everything. So starting from this general layer, we ended up with a customized version for our specific case. And yeah, let's start to look more deeply at it. So the bottommost layer is the shell, which is our naming convention for indicate a module that doesn't belong to the specific layer that we have seen, but it's just a module that contains common code, which hopefully should not become the app with another name, but it should be only a module that contains all the common DTOs, common models, maybe some scheduler providers, stuff like that, that are used between each module. And this is a special module that it's at the bottommost layer. So it doesn't depend on everything, specifically on the project, but it only depends on external libraries. And that was the shell. So now we move up, and we reach the libraries layer. And like the name suggests, in here there are libraries that are modules that abstract a specific functionalities. So again, for example, login and feature flagging and stuff like that. And those specific modules can depend on each other, because why not? Why not having a library that depends on another library? And of course, it can also depend on shell, because there could be something that is shared between multiple things. OK, now again, let's move up, and we are reaching the libraries, the feature layer, sorry. And the feature layer is containing features. Feature layers, feature modules are an abstraction of a specific feature. That could be a user-facing feature, so with UI, so with activities fragment and etc. So in that case, something that is really visible to the users. So for example, the settings, the home screen, and things like that. Or can also be something that is not directly visible to the user. So for example, the logic to retrieve the location of the user. And every feature module, every feature is composed by two modules. So we have an implementation module and a contract module. The contract module contains the API for the external world. So basically what a feature can do and how the feature can be started from external parties. And this, in reality, is just interfaces and data classes. And those type of module can depend only on libraries and can depend also on the shell, because that's where the shared things are. And then the implementation module instead, of course, contains the implementation of the contract. So it has a dependency on the contract. And this kind of module can depend only on other feature contract, because you may want to start a new feature from another feature. And it can also depend on the other bottom layers, so libraries and shell. But the only difference is that this module is invisible to the other modules, of course, except for the application, because it has to orchestrate everything. So if you need to start or reference another feature, you cannot go directly through the implementation, but you have to go through the contract. You may be wondering why. There are different reasons. The first one is that with this specific structure, you will have a low coupling between modules, because a module cannot, in this way, a module doesn't care to know the internals of another module, but just give me an interface, and I will bear with that. The second thing is that by having a contract, you can avoid the risk to having to import a lot of transitive dependencies. So if your module depends on another module, you will have to import also those. So by just using a contract, you can avoid that. And finally, the most important things of the three is that you can avoid incrementing the build time. Because if your module depends on another module, and then you are going to change the implementation details of that module, then you have to rebuild everything. But if you're depending only in the contract and you change the implementation, then you're not rebuilding everything every time. And those was the feature modules. Now we are just moving up, and we are reaching the app level. So in the app level, basically there is the app initialization, so usually the application class. And in the app module, we just initialize dependency injection. We link all the modules together. And of course, this should be kept as slim as possible, because we just want to initialize stuff. We don't want to do anything else. And so this is the ideal structure. But of course, it's ideal, and it's not real, because there's, in an existing project, there's still code that is not modularized. So the real structure is this one, with a huge red legacy module, where all the no-modularized code base is. So we wanted to have a specific module with the borders of it, where we can start from there to extract the next feature. So we decided to move everything from the app to this module to just have a proper view of it. And of course, we should try to not put new code in it, because it's legacy, but yeah, this is not working sometimes, because yeah, you are in a rush, then you have to ship new things, and the usual things. So we kept putting new code in it, but yeah, that's the usual thing. And this legacy module is basically just yet another feature module, but is special. But for that reason, it could depend on other feature contracts, because maybe you want to start a new module from the legacy code, and of course it can depend on libraries and shell, because it's just like yet another feature module. So we have this beautiful structure, and how we can stick to that. Well, first of all, we can still talk to each other, so we can write some documentation and talk to each other to try to stick to that. But since we are all humans, it's better to rely on machine. So it's better that the computer says, no, you're doing it wrong. So in order to do that, we just wrote a simple Gradle plugin to stop to fail the build if we messed up something, and it happens. So yeah, thank you for the computer that says no. Okay, so luckily, after whiteboarding and thinking and those kind of things, we have finally time to actually write some code. So in order to do that, we decided to select a specific feature to start with, because it's easier if you select something and you have a clear, concrete view of what you have to do. And the feature that you can start with can be a feature that has UI or a feature that doesn't have UI. So usually a UI feature is easier to start with because you have less things to figure out. And for example, spoiler, navigation is one of those things. And so since we are all lazy, it's better to start from stuff that are less complicated. And our choice was the code that handles the ride in the application, because we at the time we just refactored those things, so it was not legacy code, but and it was the perfect candidate of it. And if you're interested in the details of those refactoring, my colleague Daniel gave a talk on the last DrawCon, so yeah, if you're interested in the internals, that's the recording of it. And yeah, so after selecting that feature, the first thing to do is figuring out the dependencies that are used between different the legacy module, basically, and this new feature. And in order to do that, there's a really interesting Android Studio functionality that lets you select a module or select a folder, and it will generate a report of the dependencies that are used in your class. And it gives you a really nice report, and starting from that, you can understand the dependencies that are required. So after doing that, it was, of course, time to start moving those shared dependencies to the shell. And after doing that, extracting finally the first feature module. And after doing that, it was time to celebrate, because modularization is a long journey, and we have to celebrate every little things. After that, that was the structure. So still a very big application, a new shared module, and the first feature module. So at this point, it was time to create the big red legacy module and just slim the application as fast as possible. And in order to do that, of course, there are more dependencies to be moved to shell. But after that, the structure was something like that. So in total, 5 modules and a slimmer application and a big red blowing and firing legacy code. All right. So after doing the easiest things, it was time to jump into more difficult things. So it was time to extract a feature that has UI on it, so that it has activities, fragment, and stuff that are shown for real to the user. So the biggest pain point of doing that was understanding how to navigate between different modules. And basically, this was the first blocker that blocked us, because we had to basically rethink everything, rethink how navigation was done. The main reason for that is because the current setup that we had was with Japan navigation, and it still has, because guess what? The legacy is still there. But we were having Japan navigation, and every feature has its own navigation graph. But we don't have a single activity architecture. But rather, every little feature has its own activity, its own hosting activity, with fragment in it. So let's see an example. For example, we have a shopping application, and so there is the shop activity that has that feature. And inside that shop activity, there are multiple fragments. So, for example, the fragment that, to show the articles, the list of articles, the fragment to show the detail, and the fragment to show the success of the purchase. Only the success, because we only handle successful purchases. No, it's not real, but let's try to believe that. And we had this structure, and we want to keep that structure even even with modularization, because we like that, and so we want to basically, for example, start a new feature, so a new activity from the current activity. So we want to be able to do that. And we want to be able also to get a result back from after starting something. So, for example, for the classic example is the QR scanner, because we want to launch something that scans some things and that gets a result back. And the other things that we had to do, that we want to do, is the possibility to add a fragment from another module in the current flow. because there are sometimes there are places where we don't want to launch an external activity, but rather have the fragment integrated into the current flow because it looks nicer and it makes more sense. So, for example, in this case, maybe start launching the customer support fragment integrated into the shop flow, but not starting an external activity for that. And yeah, this is for covering the not success flow of that I was showing before. So, in order to do that, the first thing to start a feature, a module, a feature from another module, it's with JetBrains navigation. It's possible with deep links, but you have to have it works best with a single activity architecture and by including all the graph in the same graph. And it was not possible with our current architecture. The second thing is getting a result back. Again, is not out of the box with JetBrains navigation, but you have to start the activity for result. So we were already handling this case without JetBrains navigation. So yet another separation, two ways of doing the same concept. And finally, adding a fragment to the current navigation graph is, again, not possible out of the box with JetBrains navigation. So, in order to fix the issue, we can leverage our current contract structure. So, for starting a new feature module, we can just have a simple function in our contract interface, and then just implement it in the module implementation, and just starting the activity like in the classic way, basically. Same things for getting a result back, because we can again have a contract and just start the new activity with basically starting the activity for result with the new API. That I still have to Google it because I forgot. I kept going with the old way, but yeah. So the final thing it was adding a fragment in the current navigation graph. And we can still use the contract for that, because we can still have a function that return an instance of the fragment, but the problem is how to handle navigation, because if we are just importing a fragment from another word, then we need to in the other word the navigation is handled in some way, and in our word will be handled in another way. So we have to fix that. And in order to fix that, we decided to introduce a new pattern. So nothing new, and it was the router pattern. So basically, we decided that that a module that wants to expose a subcomponent, so basically a fragment to be integrated in another flow, has also to expose a router, which is just a fancy word to indicate yet another interface. And so for the customer support example, just an interface that has two functions, one to go back and one to start a phone call. So pretty standard. And then the module that want to import that feature has to implement an internal router for handling internal navigation, and can also implement the router from the subcomponent to handle navigation internally in its word. So, a lot of fancy words, and let's see some code that is more clear than words. And so, for this specific case, for this feature, we have internal router that is handling internal navigation. In this case, for example, is going to the map, And then is also implementing the contact support router. So it's handling internally what we want to do when we want to start the customer support call. And all these navigation events can be observed from the external world, so usually from a view model. And instead, internally is handled by a single firing relay, which is a custom relay implementation that we made that works similar like the single live event that if you have used live data in the past, you probably have copy and pasted from some Google repository. And so this relay is just, this custom implementation is just needed because we don't want to randomly trigger navigation when it's already ended. So basically, with this setup, if the navigator doesn't have any subscriber, then we're gonna emit the state to the new one, to the first new subscriber. But if there are already subscribers, then we don't remit things, so we don't take possession of the user device and just give random navigation. So this was our new approach that we decided to stick with that. And so basically, in this way, every module can manage internally the navigation. And if you want to add a single component from another module into his world, it can implement the router. And then, of course, the correct router is retrieved by using DI scoping, so dependency injection scoping. So in this way, we can be sure that the correct router is imported in the correct internal router. With that setup, we had, of course, to handle navigation manually and not with Jetpack Compose and with Jetpack navigation. And we are kind of on the process of ditching it, and which is not a big deal, in my opinion, just to start activity manually and replacing fragment manually like we used to do in the past. But the most interesting thing of this approach is that we can gradually introduce new changes, and we can, of course, unit test all the navigation logic, which is a very good thing. OK, in parallel, another thing that we had to do is improving the Gradle setup, because we were still having some version number hard-coded, which is not a good thing if you have 1,000 modules and you want to bump the version of a library. So we decided to fix everything and switch to Gradle version catalog, which is a really nice solution for managing dependencies, also because it has bundles, which that are awesome, because you can just define a set of dependency for testing or a set of dependency for your feature, and you can just import one thing and forget about everything else. Another thing to handle was the module configuration. So again, to just have a single place where to define, for example, the SDK version and not have to go to 1,000 different Gradle files to just bump a number. And for doing that, we are using build source. So we just have a Kotlin function that sets up everything. And so in the build Gradle file, we can just call this function and forget about everything else. This is the current setup. What we are planning to move to convention plugins because I think that are better than having stuff in the build source folder. And yeah, so in this way, we can just have our custom ID and just define that. But will come in the future. Another thing that was necessary was yet more automation, because I'm lazy, of course, and I want to spend time building, having to set up boilerplate. So basically, we decided to use cookie cutter, customize a little bit to have templates in order to create a feature a feature module with its implementation, its contract, and all the boilerplate that we need, just with a CLI and not that just to have to create manually two different modules, which is kind of boring things to do every time. Okay, so after this too little digression that we had to do, it's time to finally restart doing things. So finally, we can extract, create a new module with a UI feature with the new navigation. And again, like before, it was time to celebrate. But of course, after celebration, there are sad moments because there was yet another blocker. Because with the UI feature that we extracted with navigation was a little one, because you have to deal with navigation, which is a huge topic, and then you don't want to fill your time with a big module. And in this case, we realized that in order to progress forward with UI modularization, we needed some more tooling. So more modules that abstract some tooling, like, for example, feature flagging, for testing tools, and either resources, stuff like that. So again, it was time for another dependency analysis session, and some more modularization behind the scene, to finally reach a point where we can start again UI modularization. And we are now at this stage. So let's now try to wrap things up. So we started all that analysis mostly a year ago. It was July. And everything we took a year of work to be ready, to have everything in place. It seems a long journey, but I can assure that it's totally necessary, because you always found something that is not working and that is blocking. So you need to figure out everything before moving on. More specifically, in our case, we were set it up that every 6 weeks of feature development, we have just 2 weeks on complete focus on doing this kind of work. So in those 2 weeks is happening the biggest chunk of planning and work. Of course, it's not completely stopped after those 2 weeks. Otherwise, it will be not a year, but 3 years of work. But the most planning, the most kickoff stuff are happening in that period of time, and then we keep working behind to do all the things. So, as I just showed you, it's a long and difficult journey, but I can assure you that it's totally worth it, because you're gonna gain a lot of things, a lot of benefits, and I really suggest you going into that path. Unfortunately, there's no the perfect recipe, so you have to understand what is better, what is perfect for your specific solution, and in order to do that, that's why you need a lot of time for planning and for preparation. Because of that, don't be afraid to fail, because sometimes you kind of need the crystal ball to understand which is the perfect next step, and you don't know before which is the perfect solution. So sometimes you need to try things and just fail. For example, for navigation, that was not really the first idea that came out, but it took us a bit of experimentation and talking and documentation to find the perfect solution. Because of that, don't rush it. Don't try to reach 1,000 modules in 2 weeks, because it's not going to happen, and it will be you need time. And finally, it seems like more like a marketing claim, but don't refactor while modularizing. I'm not crazy. It's true, because if you can be tempted of doing that because you're looking into module, you are moving stuff around, so you will notice some interesting stuff. Let's put it that way. That you want to refactor because it was done, for example, by me one year ago, so it has to be refactored, of course. But don't do it because if you stick to refactoring, then you're not gonna have time to move stuff around. So just mark it, add a to-do, and do it later. And also, while modularizing, you will have the chance to find interesting stuff that are buried in your project. So you can find, let's say, interesting things. So for example, a user code, problem with the dependency injection graph, or yeah, let's call it interesting things. And you will have a chance to learn more and discover more of your project. So that was it for today. Those are some resources that I used for building that talk, and you're gonna find where I will share my slides later on. And so thank you very much. If we have some time, so you can ask questions. Otherwise, you can find me on Twitter or at the tier booth on the booth area. So thank you very much.